What's up, Integrated One students? Today we're going to talk about interior angles and exterior angles of a polygon. So let me draw a square. If I want to figure out the total measure of the interior angles of a polygon, so the interior angles are these angles right here. So I want to find the measure of the interior angles of this square. How can I do that? Well, take a look at what happens when we draw a line from one corner to an opposite corner in a square. Now we've made the square into two triangles, right? And how many degrees does a triangle have in it? 180. So this triangle has 180 degrees in it. And this triangle has 180 degrees in it. And all of the angles of these triangles are located on the interior angles of this square. There's no like angles in the middle right here that aren't at a corner. So to figure out how much the interior angles of this square sum to, like what the sum total of the interior angles of this square is, it's 180 times 2, which is 360. Let's look at a pentagon. So this is a pentagon. We can do a similar thing. If we start at this top point, we can draw lines to every corner that isn't directly opposite. Like we can't draw a line to this corner because that goes right along the side. So if I draw these kind of lines in a pentagon, I've split the pentagon into 3 triangles again. And each of these 3 triangles have 180 degrees, 180 degrees, and 180 degrees. So how many angles, what's the sum total of the interior angles of a pentagon, do you think? Well, we have 3 triangles. All 3 corners of those triangles are at interior angles of this pentagon. So the total measure of the interior angles of this pentagon will be 180 times 3, which is 540, I think. Yeah, 540. Okay, so maybe we see a pattern here. With a square, we could divide it into a figure with 4 sides, a square. We could divide it into 2 triangles, and that gave us a total measure of the interior angles of 360 degrees. With a pentagon, which has 5 sides, we were able to divide it into 3 triangles, which gave us a total interior angle measure of 180 times 3, which is 540. So let's look at one more, just to make sure that we get this right. So let's draw an octagon. I'm going to do the same thing. I'm going to take one corner of the octagon, and I'm going to connect it to opposite corners. I've made 1, 2, 3, 4, 5, 6 triangles now. So this is an 8-sided figure, and I've made 6 triangles. So because there's 6 triangles inside this figure, the measure of the interior angles will be 180 times 6, which is 600 plus 480, 1080, which is an awesome snowboarding game. Okay, so see if you can spot a pattern here. With a 4-sided figure, we multiplied 180 by 2. With a 5-sided figure, we multiplied 180 by 3. With an 8-sided figure, we multiplied 180 by 6.